Hi students. So today I will discuss one more topic, that is transfer of heat part 2. I already did part 1 and also uploaded. So if you did not watch, please watch it. So here part 2 will discuss somewhat more applications based on the conductors now, right? So thermal conductivity, so like that. So just we'll recall it. So what we discussed now, conduction. So there is a one conductor is there, one a rod is there. This rod is maintained at two different temperatures. Suppose higher temperature 100 degrees centigrade, lower temperature 0 degrees centigrade. At a steady state, means what? Whatever the, if you consider one small amount of area, whatever the energy entering to this area, that much amount of energy will be leaving now. So therefore here whatever the rate of flow of heat, so the power which is entering, which will be equal to Q by T, which is leaving now. So and also we calculated, this is called steady state condition, steady state. Now we already derived Q by T, it will be equal to K into A into delta T by L. So this is the formula for rate of flow of heat energy. Now we'll see some of the applications based on this one now. Now very simple question now. Suppose there is a one conductor is there. So this is one conductor. So having length is about 30 centimeter. Okay. So this side end it is given as 100 degrees centigrade. Other end it is given as 20 degrees centigrade. We want to calculate what will be the temperature on this rod at a distance of 10 centimeter. 10 centimeter. So therefore at this point, what is the temperature at this point? No, we want to calculate it. So how to calculate now at the steady state? No, the same way. So this rod it will be the same. So thermal conductivity will be the same. Area of cross section is also same onto this one. No? So how much amount of heat is entering, that much amount of heat it will be leaving on this one. No? So rate of flow of heat energy which is entering and rate of flow of heat energy which is leaving, so should be equal onto this. So what is the rate of flow of heat energy? Now we written the formula K into A into, so 100 minus T divided by length is how much? No, 10 centimeter. So this side is also K into A into, so what will be the temperature difference now? T minus 20, so divided by, so remaining other distance is about 20 centimeter. Why? Because total length is 30 centimeter. Centimeter, no problem. So this Ka, this is 1, this is 2. So taken here, no, we can calculate it, no. So here 2 into 100 minus T, it will be equal to T minus 20. Therefore here 200 minus 2T is equals to T minus 20. This taken here, no, this taken here. 200 plus 20, 220 is equals to 3T. That implies T is equals to 220 divided by 3 degrees centigrade, no, will be your answer on this. Clear? In this way you can calculate thermal resistance. What is mean by this thermal resistance now? That is, so to flow the heat energy, to flow the heat energy, there is an opposition now. This opposition we will call it opposition to flow of heat energy, we will call it as like a thermal resistance. A good conductor will be having lower thermal resistance, no. So like one insulator will be having higher thermal resistance. So resistance means you already heard one word, that is in the current electricity we studied. So what is this one now? So here there is a one resistance is there. This is one resistance and it is connected by one potential difference, no. So potential difference, current it will be flowing. We written the Ohm's law. Ohm's law, what you can write it now? V is equals to IR, or R is equals to V by I. So V is what? Potential difference. Potential difference making the current to flow. divided by the current. Current is nothing but a rate of flow of charges. Clear? So like this we studied now exactly the same thing. Also we studied resistance. So resistance is equals to rho into L by A. Rho is what? Resistivity. If you want to write down in conductivity, so therefore here resistivity is equals to 1 by sigma. This is conductivity. So what you can write it now? L by sigma into A. So this is in terms of resistivity, in terms of conductivity. Clear? Now exactly for our thermal resistance also, so we are going to define exactly the same way. Therefore thermal, here current is flowing, charges are flowing, here heat will flow. So here there is a one rod is there, no, this is one rod. So why the heat will flow? Because of due to the temperature difference. So what will be the temperature difference here now? So temperature difference like your battery. So this is your temperature difference. So what it will flow now? Heat will flow. That is, heat is nothing but a Q by T, rate of flow of heat energy. Here charges will flow, charge per unit time. So it is nothing but like a current. So therefore we can write down thermal resistance, no. So what is the resistance now? Which is making the current to flow? Potential difference. Which is making to flow heat energy? Temperature difference. What is flowing current? Here rate of flow of heat energy. Clear? So we written one formula, rate of flow of heat energy K into A into delta T by it is L. So what I can write now? This Q by T I am taking now. This I am taking L by Ka is equals to delta T by Q by T. Clear? So here we can write down. So delta T by Q by T is nothing but a L by Ka. Clear? So this is exactly the same. Therefore L is directly proportional length, inversely proportional to conductivity. Here inversely proportional to thermal conductivity. Area, it is area. Clear? So this is a thermal resistance formula. What is the unit now? So temperature difference, no, that is nothing but Kelvin per, therefore it is watt. So what is the dimensional formula here now? We can rewrite it as Kelvin, and watt is nothing but a M1 L2 T minus 3 taken top, no, M minus 1 L minus 2 T3 K1 will be the dimensional formula for the resistance, thermal resistance on this, right? So it depends upon the length and so it is length and inversely proportional to area, and it will be the K onto this, right? So this is a thermal resistance, no, so we can calculate it. So I will tell you one small shortcut onto this one, no. Whatever may be the problems, like rods are connected in series, parallel, or any different combinations, no. So just a rod you need to replace with a resistor, then you can solve like a solving of our circuit problems in our we studied in current electricity, like that only exactly we have to solve it now. So for sample purpose, no, so we'll do like rods are connected in series and parallel, then we'll go for some combinations on this. Clear? So this is the thermal resistance, no, very important now. So now we'll go for rods are connected in series. Rods are in series. Suppose there are two rods are there now. So there are two rods are there. So suppose here this is one rod of length, it will be L1, so having K1, and another one more rod is there. So one more rod here, therefore here it will be K2, thermal conductivity, length is L2. So area of cross section we will take it as same. Maintain at temperature difference of about suppose temperature difference T1 and this temperature difference is T2, delta theta. So how to rewrite this one now? This combination is exactly, no need to think anything onto this one, no. Exactly this rod can be assumed to be like a one resistance. This rod can also be assumed to be like a one resistance, and this is connected to like a temperature difference. That's all. What is the current now? Rate of flow of heat energy. So this is R1, this is R2. How to write it now? L1 or L2 by K2 into A. So therefore L1 by K1 into A. So when the rods are connected in series, so means here resistors are connected in series, what will be the condition now? Current through them, it will be the same. Current flowing through them, it will be constant. Clear? Current, it will be the same onto this. So but what it will be the difference now? Potential difference. So here temperature difference across this one different, temperature difference across this one is different. So how to solve the problems? Exactly like our circuit problems. So current electricity circuit problems, no, like that only how to solve these problems now. Right? We want to write down K equivalent down. How we will write it now? Now resistors are connected in series. So what you can write it now? R equivalent is equals to R1 plus R2. So R equivalent, what is R1 now? Therefore L1 by K1 into A plus L2 by K2 into A. But here R equivalent of this one now, what will happen now? Total length it will become like a L1 plus L2 by K equivalent into A. Clear? Now this A can be taken common, it can be cancelled here now. So K equivalent, what you can write it now? K equivalent taken here no. So L1 plus L2 by L1 by K1 plus L2 by K2. Like this you can rewrite it as when the rods are connected in series. Right? If lengths are also same, what you can write it now? 2L. So therefore L taken common, K1 plus K2 by taken here now. If K equivalent it will be equal to 2K1 K2 by K1 plus K2. So which what is the condition now? L1 is equals to L2, A1 is equals to A2. Clear? So first like n number of rods are there now. If they are connected in like series now, how to write it now? You can remember this one now. So here L1 plus L2 plus so on up to Ln by K equivalent, it will be equal to L1 by K1 plus L2 by K2 plus so on Ln by therefore Kn. This it will be your so combination of rods are connected in series now. Clear? Here one more important point you need to understand here. So very important concept now. We want to calculate what will be the junction temperature at this point. So what is the junction temperature now? Like this junction temperature we want to calculate junction temperature. So that means here what will be the potential difference like that. Okay, the junction temperature now you want to calculate. How to calculate now? It is steady state. Steady state means what? How much amount of current is entering, that much amount of current has to leave. Correct? So exactly you want to calculate the junction temperature. Junction temperature. How to do it now? Therefore here the two rods are there no. Therefore here it is K1 into L1 and another one more rod is there. So that is nothing but a here. Therefore here K2 into L2. So here temperature is there no. Therefore it is T1 and therefore temperature it will be T2. Therefore this temperature is nothing but a T. So here what will happen now? Here how much amount of heat is entering, that much amount of heat it will be leaving now. Right? So how to write it now? Exactly the same. Q by T which is entering. So it will be equal to Q by T which is leaving. Q by T is nothing but what? So K. Therefore K1 into A into therefore T1 minus T divided by therefore L1. This length is L1 is equals to this one now. Therefore K2 into A into T minus T2 divided by L2. So here area of cross section is same, therefore we will cancel it now. So therefore we can rewrite it as just to simplify mathematics now. So therefore here K1 T1 by L1. So K1 T1 by L1. Here K2 T2 by L2 minus is there taken here no. Therefore K2 T2 by L2. So here K1 by L1 T taken here no. So that means T taken common no. Therefore K1 by L1 plus K2 by L2. Clear? So here we can rewrite it as T is equals to K1 T1 by L1 plus K2 T2 by L2 by K1 by L1 plus K2 by L2. This is your junction temperature. Right? I suggest you please don't memorize this any other formula, but try to remember that. So here which is important no. steady state condition is there, no? This steady state condition, so this only is important, no? Right? So if you are able to write it, no, then you can try to write like this formulas, then you can simply solve it, no? So instead of remembering the formulas, don't remember the formula. This is junction temperature, no? Now we'll go for now. So rods are connected in parallel. Now so rods are connected in parallel. So means what here now? There is a one rod is there, no? This one rod. So having length is L. So therefore it is L having K1, and another one more rod is there. Another one more rod is there. That is nothing but a here. So here, therefore also L, it is K2. Therefore area is A2, and here area is A1. Now these are connected to one temperature junction and another temperature junction T1 and T2. Clear? So here also how to solve this type of problems? No, exactly the same way, again same story. So here resistance, no, R1, here another one more resistance is R2. So how they are connected now? They are connected like this. It is about temperature difference. So what it will flow? Rate of heat it will flow, current it will flow. So when it is coming here, no, what will happen now? Current will be divided in such a way that, so the potential difference, that is temperature difference across the sun, temperature difference across the sun will be same. Like that it will be exactly how we are solving, same way. Now we know that, so R1 is what is the formula? L by, therefore K1 into A1. So R2 is nothing but a L by K2 into A2. So how they are connected now? So they are connected in parallel, therefore 1 by R equivalent, therefore 1 by R1 plus 1 by R2. So R equivalent, so let us write down. So first of all R1, 1 by R1, R1 is nothing but L by K. So 1 by R1 means what? So K1 into A1 by L plus therefore K2 into A2 by L. So here you can write down K equivalent into area is added. This is area A1 and area A2. So A1 plus A2, but lengths are same. Clear? So then length taken common now. So we can cancel it. So then we can rewrite it as K equivalent is nothing but K1 A1 plus K2 A2 by therefore A1 plus A2. So this it will be your K equivalent. Clear? In this way, so we can solve the problems. So whenever they are connected in parallel onto this one. Clear? So this also very important. If area and A1 and A2 are also equal, so what you can get it now? K equivalent, no? That is nothing but a K1 plus K2 by 2. So this is L1 and L2 are also equal. Okay? So this is the condition now. Clear? So in this way, you can solve the problems if they are connected in parallel onto this. Right? So we'll see one question here now. How much time? Right. So we'll solve some questions on this one. No? Suppose let us take this one question. No? So here there is a one rod is there. No? This is one rod. Right. Another one more rod is there. No? So here. So this is K1. It will be equal to 10 SI unit. K2 is equals to suppose 20 SI unit. So here length is L1 is equals to 20 centimeter, L2 is equals to 10 centimeter now. Therefore, this side it will be about 100 degrees centigrade is connected to 100 degrees centigrade, and this side connected to 20 degrees centigrade now, right? So we want to calculate so many things now here. So first of all, K equivalent we want to calculate. What is the K equivalent onto this one now? So when there is a rods are connected in this are connected in series onto this. So how you can write it now? L1 plus L2 by K equivalent is equals to L1 by K1 by L2 by K2. Area of this one it will be the same. Area you can write down like a 0.1. So therefore like we can write down 10 centimeter square. Okay. So 10 centimeter square. Okay, so both the areas are same. What you can write it now? Length L, how much it will be? So now 10 and 10 plus 20, therefore 30 by K equivalent. So it is nothing but a centimeters are then you can cancel it, no? So K1 is 10, its length is 20, 20 by, so it is 10 plus, so therefore here L2 is 10 by 20. How much it will be now? This is 2 plus 1 by 2, therefore it is nothing but a 2 plus 1 by 2, therefore 2.5, that is nothing but a 5 by 2. So what you can write it now? K equivalent, no? So here, so K equivalent 30 into 2 by 5, 5 ones are 5 6 are, therefore 12. So in SI unit, no? What is the SI unit, no? So watt per meter Kelvin, no? Clear? So this is your K equivalent now. Clear? So we want to calculate the junction temperature also. Here junction temperature, no? How to calculate the junction temperature? Is a very simple concept, no? You can solve very easily. So what is the junction temperature here, no? So here how much amount of heat is entering and that much amount of heat has to leave here. So what is how much heat is entering now? So here K is how much, no? 10. It is in SI unit into area. Area is how much, no? 10 centimeter square means 10 to the power of minus 4 meter square. It is in SI unit, right? So this is SI unit, we have to convert it now, right? 10 centimeter square means 10 into 10 to the power of minus 4 area into temperature difference is how much now? 100 minus T. So 100 minus T, so divided by, therefore, so it will be equal to length of this one, 20 into 10 to the power of minus 2. This is equal to, so what you can write it now here? So here it will be K value is 20 SI unit only into area is also same 10 into 10 to the power of minus 4 into, therefore here, so T minus 20 divided by 10 centimeter, 10 into 10 to the power of minus 2. So simplify, what you can get it now? This side, so this is get cancelled out, this is also get cancelled out. So here, okay, this denominator gone. So here 2 1s are 2 5s are, therefore 5 into 10 to the power of minus 3, 5 into 10 to the power of minus 3. So here into 100 minus T, it will be equal to this way I can take it now, 20 into 10 to the power of minus 3 into T minus 20. Clear? So therefore 10 to the power of minus 3 get cancelled, 5 1s are 5 4s are. Clear? So now you can solve it now. Therefore 100 minus T, it will be equal to 40 minus 80. So multiply with 4. So taken here now, 5T is equals to 180. So T is equals to 180 by 5, 5 1s are 5 3s are 15, so 30, therefore 6, so 36 degrees centigrade. Clear? So in this way we can calculate the junction temperature. And also they may ask you, so one more question now here. Therefore K equivalent we got it now. K equivalent we got it. Also junction temperature we got it now. And one more, what will be the total net rate of flow of heat energy? What is the rate of flow of heat energy? So that is nothing but a K equivalent into area of cross section, total temperature difference, no? Delta T divided by length, therefore L1 plus L2. In this way, therefore rate of flow of heat energy we can calculate it now. Now let us see how much amount of rate of flow of heat energy is there now for this question. Now here, now see this one, here rate of flow of heat energy. So this is your this is the first question now, and this is your second question, this is your third question. Clear? Right. How to find it now? Rate of flow of heat energy, K equivalent, I got it in the SI unit now, 12 into area 10 into 10 to the power of minus 4 into temperature difference is how much now? 80 divided by length is nothing but a 30 into 10 to the power of minus 2. Clear? These two zeros I can take it out 10 to the power minus 2, therefore this will get cancelled out. So therefore 12 into 8 divided by 30. So therefore now 3 10s are 3 4s are, therefore how much it will be? So 8 4s are 32, 32 divided by 10, how much now? Therefore 3.2, so joules per second, this much amount of energy it will be flows through this one. Clear? Like these questions also you can expect it, no? So now like some more questions, no, we'll discuss. Here there is a one question. Suppose there is a 3 rods are there. Suppose these are the 3 rods are there. This side it is about 100 degrees centigrade. This is 2K. Therefore here it is 3K. It is about 20 degrees centigrade. Here it is also K. It is K. Therefore 30 degree centigrade. Length it will be equal to 10 centimeter. So here L1, L2 it will be equal to 20 centimeter. So L3 is equals to 30 centimeter now, right? So area of cross sections all are same. Therefore we want to calculate the what will be the junction temperature on this one now, junction temperature. So which is hot body here now? Hot junction. This side is a hot junction now. So therefore definitely heat will flow from this hot junction and it will be able to enter to this, right? So this side it is entering and these two are leaving onto this one. So here we can rewrite it as, so how much amount of rate of flow of heat entering, that much amount of rate of flow of heat therefore leaving on this. Rate of flow of heat how much now? Here K is how much now? This is 2K into area of cross section, all area of cross sections are same, okay, into temperature difference. Temperature difference is how much now? 100 minus T divided by length is equals to 10. So is equals to, so leaving is what? For the two things are there. Therefore here 3K into area of cross section into T minus 20 divided by therefore 20 centimeter plus, so here therefore it will be K into A, so into T minus 30 divided by therefore 30 centimeter. So even if you want to write out 10 to the power minus 2, 10 to the power minus 2, 10 to the power minus 2, cancel no. So it's no problem now. Here K also cancel. K and 0, K and 0, K and 0 will be cancelled onto this. So what I can get it now? 2 into okay. So 2 into 100 minus T, it will be equal to, therefore here 3 by 2 into T minus 20, so plus therefore T minus 30 divided by 3. So here denominator if I want to make it cancel, I multiply 6 now. So therefore what I will get it now? Multiply 6, therefore it will be 12. So here multiply 6 now, here total junction, total it will be multiplied with 6. Therefore here 12 into 100 minus T, it will be equal to 6. I multiplied here no. 6 means 2 into 3, 3 is a 9, 9 into T minus 20 plus 3 2s are, therefore 2 into T minus 30. Simplify, you can get your answer now. So 1200 minus 12T is equals to 90 minus 180 plus 2T minus 60. Now how much it will be here? Here 180 plus 60, therefore here it will be 240 taken here no. 1200 plus 240 is nothing but a 1440, this taken here no. 12T, this is 9 plus 2 11T, 11, therefore 23T. So T is equals to 1440 divided by 23 degrees centigrade. This it will be your junction temperature. Like these problems, no, you can able to solve it, right? So therefore we will do like one numerical based part, no. So for fully on the transfer of heat in the next part, no. So thank you for watching my video. So please subscribe to my channel.